Hello, what is the value of a? Given that you have a to the power of 6 minus 64 equals 0. Then let's have it to be solution from here. From here, we must know that from here, we can have a to the power of 6 to be, taking this one to here, we have it to be 64. Then, we must know that we can have 64 in base 2 as 2 to the power of 6. So when we substitute it here, we can have it to be a to the power of 6 equals 2 to the power of 6. Then let us recall that when we have a to the power of m to be equals b to the power of m. So far they have the same power. This implies that a will be equals b from here. So by applying it here, we can say we have a to be equals 2. And the reason is that they have the same power as this. So, but from here, we can tell you that a equals 2 is not the only solution for this problem. Let's solve for the other solution. You know, we have a to the power of 6 minus 64 to be equals 0. So from here, you can have 8 to the power of 2 to be equals 64. So from here, we have a to the power of 6 minus 8 to the power of 2 equals 0. Then let's re-express, we can have 6 as 3 times 2. So here will be a to the power of 3 times 2 minus 8 to the power of 2 equals 0. Then let us recall that when we have a to the power of m in parentheses to the power of n, can be simplified as a to the power of n by interchanging the power, put them in parentheses as to the power of n. Meaning that we can have this as a to the power of 3 in parentheses to the power of 2 as this minus 8 to the power of 2 equals 0. And when we consider this power and this power here, this is the difference of 2 square. Recall that when we have a square minus b square equals as a plus b in parentheses, then multiply by again a minus b in parentheses. So when we make the comparison of this with this one, we will discover that our a will be equals a to the power of 3 from here, and our b will be equals 8. So from here we can have it to be a to the power of 3, then it will be plus b is 8, then multiply by a to the power of 3 minus 8 equals 0 from this. Now for this expression to be equals 0, is either we have, let's say case 1, is either we have a to the power of 3 plus 8 equals 0. Then let's say case 2, a to the power of 3 minus 8 to be equals 0. Is either we have this one to be 0, when we multiply with this, here will be 0. Or we have this to be 0, when we multiply by this, it will give us 0. So from here, let us now recall that when we have x to the power of 3, or we can have a to the power of 3. Let's have 8 in base 2 as 2 to the power of 3 still equals 0. This also a to the power of 3 minus 2 to the power of 3 still equals 0. We have them in power 3, and this, we can say this one is the sum of 2 cube when we have x to the power of 3 plus y to the power of 3, sum of 2 cube. This equals as when we have x plus y multiplied by x square minus xy plus y square. So when you apply it to this, we are going to have a plus 2 in parentheses multiplied by a square minus 2 a plus our y will be 2, here will be 2 square, still equals 0. let's leave this one first. So from here we have a plus 2 in parentheses multiplied by a square minus 2a plus 4 equals 0. So for this expression to be equal 0 again, it's either we have a plus 2 equals 0, or we have a square minus 2a plus 4 to be equals 0. And so therefore we have a to be equals minus 2. Then from here, to get the possible value of a, you can apply the quadratic formula where we are going to have a to be equals minus b, positive or negative, square root of b square minus 4ac divided by 2a, where the parameter a of this, the coefficient of a square here is 1, and this b equal the coefficient of a, which is minus 2, then c equals 4. So when we substitute everything here, we are going to have a to be equals, here is already minus 2, here will be minus, then into minus 2, positive or negative, root of minus 2 in parentheses to the power of 2, 4 multiplied by a is 1, multiplied by c, our c is 4, then all divided by 2 times 1. So from here we have a to be equals, minus times minus will give us 2, root of this minus 2 in parentheses to the power of 2 will give us 4, 4 times 1 is 4 times this will give us 16 divided by 2, and this will be equals 2, positive or negative, root of 4 minus 16 will give us minus 12 divided by 2. So we have a 2, positive or negative, root of 4 times 3. 4 times 3 will give us 12, multiplied by root of minus 1 divided by 2. But root of minus 1 equals I from a complex number. Then when we have root 4 times 3 equals as root 4 multiplied by root 3, and this will be equals root 4 will give us 2 multiplied by root 3. So from here we have a to be equals 2, positive or negative, 2 root 3i, then all divided by 2. So from here, let's divide through by 2, 2 divided by 2, positive or negative, 2 multiplied by root 3i, also divided by 2. So when this divided by this will give us 1, positive or negative. When this divided by this will be 1 times root 3i, will give us root 3i. So therefore, we have a to be equals minus 2 and 1 positive or negative root 3i. These are our complex solution, these are our least solution. Then let's also recall from case 2, where we have a to the power of 3 minus 2 to the power of 3 that equals 0. Recall also that when we have x to the power of 3 minus y to the power of 3, we can have this as x minus y multiplied by x squared plus xy plus y squared. We call this difference of 2 cube. When we apply it here, we discover that our x equals a, then our y equals 2. Then when we substitute everything here, we are going to have here to be a minus 2, then multiplied by x squared is a, so here will be a squared plus 2a plus 2 squared, then everything equals 0. So we have a minus 2 multiplied by a squared plus 2a plus 4 equals 0. 2 squared will give us 4. Then for this expression to be equal 0, so that we have a minus 2 to be equal 0, or we have a squared plus 2a plus 4 to be equal 0. Obviously from here we have a to be equals 2. Then from here also, when we apply the quadratic formula, where we are going to have a to be equals minus b, positive or negative, roots of b squared minus 4 AC divided by 2A, where we have parameter A to be equals the coefficient of x squared 1, A squared 1, B, the coefficient of A is 2, then our C will be 4. So when we substitute everything here, we have A to be equals minus 2, positive or negative, root of 2 square, 4 times A is 1 times C is 4, then divided by 2 times 1. So we have A to be equals minus 2, positive or negative, root of 2 square will give us 4 minus 16 divided by 2. Then this equals minus 2, positive or negative, root of minus 12 divided by 2. So from here we have A to be equals minus 2, positive or negative. We can have 12 as the product of 4 times 3 multiplied by root of minus 1 divided by 2. So A will now be equals minus 2, positive or negative, root 4 will give us 2 multiplied by root 3. Then root of minus 1 equals I in a complex number, root 3I divided by 2. Let's divide 2 by 2. Here will be minus 2 divided by 2, positive or negative, 2 multiplied by root 3I divided by 2. So we have A, minus 2 divided by 2 will be minus 1, positive or negative, and this divided by this will give us 1, multiplied by this we have root 3I. Then we also have A to be equals 2. So note that we also have A to be equals 1, positive or negative, root 3I, then A equals minus 2. These are the real solution, while these are the what complex solutions. So if you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more math tutorial videos. Then you can say to check, we have A to the power of 6 minus 64 to be equals 0. So from here, when we have this first, it will be 2 to the power of 6, which is 64 minus 64, it will be equals 0. So 0 from here equals 0. Likewise, minus 2, this again, to the power of 6 minus 64, then it's going to give us 0. Anytime when you have a negative to the power of even, it will give you plus 2 to the power of 6, which equals 64 minus 64 equals 0. 0 equals 0. Bye bye.